We talked previously about relations, and a relation is just a set of ordered pairs or a set of coordinates. Function is a specific type of relation. A function is still a set of ordered pairs, but specifically it is a set of ordered pairs in which each element of the domain is paired with exactly one element of the range. And I've got two examples for you right here at the top. The first is a mapping where each piece of this mapping is showing that an element of the domain matches exactly one element of the range. So right here we've got the 1 matched with the 4, the 2 matched with the 5, and the 3 matched with the 6. Each element of that domain matches exactly one element of the range. In fact, I could even make things a little bit more complicated here, and I could make the 3, for example. Um, let's add one more number. Let's put like a 4 down here. Let's make the 4 match the 6 also. And this is still okay. To have the 3 and the 4 both going to the 6, this is still a function because each element of the domain, which is our first mapping here, let me do a better job here of labeling x and y. Each element of our domain matches exactly one element of the range. It's okay that we have two things in the domain going to the same thing in the range. That's fine. It's still a function. If I wanted to make this not a function, I would do something like this. Now it's not a function anymore because now I have an element of the domain, that number 1, that is going to two elements of the range. The 1 is going to the 4 and the 1 is going to the 5. So that makes it not a function anymore because one element of the domain is now going to two elements of the range. This graph, on the other hand, also a function because it passes what is called the vertical line test. And the vertical line test works like this. If I take a vertical line like this ruler and I move the ruler across this line, there is no point at which the ruler touches the graph more than one time. If I move this vertical line across, it only ever touches the graph once. So this is a function. If I wanted to make this something that was not a function, I could put a point right here, for example. Now it's not a function because as I move across, it's only touching the graph one time until I get here. And now it's touching the graph in two spots. It's touching the graph at this point, and it's touching the graph right there at that point. It's no longer a function because it touches the graph in two different spots. That makes it not a function. Okay, so let's take a look at these two examples down here. Is this a function? Well, the easiest way to check is to look at these objects in the domain and ask ourselves, are any of these pieces of the domain going to more than one thing in the range? And the simplest way to check is, do we have more than one arrow going for many of these things in the domain? And the answer is no. Each element of the domain only has one arrow coming from it, which means they can't be going to more than one element of the range. If we come over and look at this table, we're asking ourselves a similar question. Do we have anything in the domain that matches to more than one thing in the range? And the answer is yes. We have something in the domain that is repeated. This number 1 appears in the domain twice, and that would be okay if its corresponding element in the range was the same, but it's not. The first number 1 matches up to 4, and the second number 1 matches to -4. So this is not a function because of those two ordered pairs, 1, 4 and 1, -4. This one, on the other hand, is a function because each element of the domain corresponds to exactly one element of the range.